Well, welcome, and thank you all for coming. I'm going to talk a little bit about the format first, because this is a little different, and then we'll get started. So there's going to be 5 talks of about 15 minutes each. And after that, a short break. We'll come back in here for a question period, which will be for about an hour. And then anybody who wants to continue the conversation is invited to join us in the dining hall for dinner. Now, this panel is the result of a study group in the philosophy of biology that's been going on all year. It's involved tutors and students and colleagues from Northern New Mexico College in Espanola. And I want to start by thanking everybody who's been participating in that group, because it's been very stimulating. And as a result of our work there, each of us wrote on something about our own interest in biology as a liberal art. And when we got all our papers together, we were really surprised and pleased at the ways they played off each other and took up similar themes. So we are hoping today that for the question period, we can concentrate on looking at some of the bigger issues and the ways these are all interrelated. And we're going to ask everybody to hold questions and applause to the very end of the presentation, so we won't have anything in between presentations. And I'll be introducing everyone. My name's Linda Wiener, and my paper is called Nature as Object and Nature as Relationship. So according to the St. John's College catalog, St. John's College is a community dedicated to liberal education. Such education seeks to free men and women from the tyrannies of unexamined opinions and inherited prejudices. At St. John's, freedom is pursued mainly through thoughtful conversation about great books of the Western tradition. They change our minds, move our hearts, and touch our spirits. So mostly we're reading and talking about books here, but in the laboratory program, we attempt to have some contact with the book of nature. And our biology program is split into 2 parts. At the very beginning of freshman year, we do observational biology, and at the very end of senior year, we do evolution and genetics. So we start as naive observers looking at part of a meadow, and we end with a more modern scientific view of biology in terms of DNA and its function in a cell. But really, we're never naive observers. We come here with a prior education in biology, and we're exposed to all of the cultural views through TV and newspaper articles and things like that. And the 2 major strands of biology education in our culture today are genetics and environmental sciences. And the story of DNA is a triumphal story of the discovery of the key of life. A quick survey of recent stories in the Huffington Post on genetics yielded articles on genes for crime, for educational attainment, for the desire to be thin, for the desire to eat meat, for baldness, for gayness, and for cancer. So everything, and so advances in genetic engineering technology tend to be announced with lots of exclamation points. So for instance, the genetically modified crops have up to 100 times more lysine than traditional crops do. Dutch bioengineers are genetically modifying petunias to act as vaccine-producing factories. So in this narrative, human scientists have figured out the key to life, and we can manipulate its key component, DNA, and make humans and other organisms meet our specifications. The world in this narrative is not as it should be. Humans have bad genes, and we can test for them and fix them with surgery in the womb. And rice has vitamin A deficiency, which we can fix with genes from a daffodil. So on the other side, the other is the environmental sciences, and they look at subjects such as biodiversity and ecosystem change. And they contrast native, healthy ecosystems with polluted and invaded habitats and attempt to instill an environmental ethic, which has come to include such topics as recycling, habitat restoration, and animal welfare. So a quick search again of the Huffington Post for what's called green stories yielded articles on climate change and how it's affecting the Arctic ecosystem, on toxic chemicals in the water, but also articles on orca slavery at SeaWorld and the abuse of animals on factory farms. So in this narrative, humans are the problem rather than the solution. We're the ones that are ruining the world, which is otherwise seen as natural and good. So, and in our schools from the earliest ages, biology is taught as a science. And so you're learning facts and systems of facts. And if I looked at the New Mexico science standards for the life sciences for kindergarten through 4th grade, and they begin, quote, understand the properties, structures, and processes of living things and the interdependence of living things and their environments. And know that living things have diverse forms, structures, functions, and habitats. Specific performance standards involve such things as know that humans and other living things have senses to help detect stimuli, and that sensations and stimuli influence the behavior of organisms. So in our biology education, plants and animals are treated as material objects, and we study them in terms of stimuli and organ systems. Now, if you were allowed to run free in forests or deserts or even an urban park as a child, you probably had the chance to experience nature as something that you were embedded in a profound way, that you were connected to. And this experience could involve just running around and finding interesting things, or do little civil engineering projects in streams and make little dams for the fish, and you collect plants and animals and rocks and you bring them home. And if you grew up with pets, you also had the experience of a relationship with a being from a different species. And pets were animals that you played with, talked to, commiserated with, had relationships with. Now, if I go into a 2nd grade classroom or a 4th grade classroom and do a class on my specialty, which is insects and spiders, I start by asking, what kinds of questions they have. And they always have a lot of questions, and those questions start from a kind of relationship with nature. So they always want to know, will Daddy Longlegs kill you? And they want to talk about what happened when their dog ate a stink bug and how it feels when a ladybug walks on their hand. And so they're very excited about these conversations, and they're also excited to go outside and catch bugs in jars and look at them and talk about what they're doing. Now, these kinds of activities are today often discouraged. For instance, there's a debate going on in the biological community about whether collecting plants or insects is a possible thing to have young children do, or even college students. Dr. Walter Gould, an entomologist responding to a child who wanted to start an insect collection, says this: I really enjoyed collecting when I was a kid, but ethically, I think that most people would be troubled by killing something for no other reason than to put something in a box and admire it. I don't encourage collecting. I think that it is in the category of big game trophy hunting, of being not considered ethical by a majority of the population. And this view is also continued in our culture. There's a position that views the use of animals as food or clothing, or even the owning of pets, as a violation of ethics. So this next quotation is from People for the Ethical Treatment of Animals, or PETA. The selfish desire to possess animals and receive love from them causes immeasurable suffering, which results from manipulating their breeding, selling or giving them away casually, and depriving them of the opportunity to engage in their natural behavior. They are restricted to human homes where they must obey commands and can only eat, drink, and even urinate when humans allow them to. Because domesticated animals retain many of their basic instincts and drives, but are not able to survive on their own in the wild, dogs, cats, or birds whose strongest desire is to be free must be confined to houses, yards, or cages for their own safety. So there's both these prevalent views are taught in our schools, and they're sort of around in our culture, and they see humans as not essentially a part of and in relationship to nature, but opposed to it. Genetic science sees us as masters of the universe who understand and can therefore manipulate life, so which everything is permissible in genetic engineering. And the environmental or green sciences view humans as perverters of a natural order to which we are alien. And in that narrative, nothing is permitted. So, and both of these views arouse an intellectual and moral passion about nature, but neither of them moves our hearts or touches our spirit from a fundamental relationship with and embeddedness in the world. So this is perplexing territory, and what does it have to do with biology education? So I want to focus the remainder of this short talk on how we come to our relationship and understanding of the natural world pre-scientifically, and how reflection on this pre-scientific experience might inform our scientific understanding. And I hope to show that our first encounters with the world should remain present to us, and that these originary experiences really, they do move our hearts and they do touch our spirits, and they ignite our intellectual curiosity and can lead to the sort of dedication that scientific work requires, but at the same time, it leads to a genuine care for organisms which we share our world with. I'm drawing here from the seminal work of Maurice, Merleau-Ponty, in the Phenomenology of Perception. So the viewpoint of phenomenology switches the usual scientific view that we've inherited from our own educations. We're not disembodied consciousnesses who constitute the world through our sensations, but we're beings who are born into a world that's already given and accepted by us. And our relationship with the world results from the situation of our physical bodies in that world. Merleau-Ponty writes, "The relations between things or aspects of things, having always our body as their vehicle, the whole of nature is the setting of our own life, or our interlocutor in a sort of dialogue. Every perception is a communication or a communion." And a little further down, he says, "It is simply a question of recognizing that the body, as science sees it, as a chemical structure or an agglomeration of tissues, is formed by a process of impoverishment from a primordial phenomenon of the body for us, the body of human experience." So even a game of fetch that you play with a dog can show you something of this. When I'm playing with my dog and a stick, we're sort of make up the rules together, and we vary the play together. And when I'm involved in a game like that, my dog is not for me a creature that is reacting to stimuli through its sensations. It's my playmate. And equally foreign to this game of fetch with my dog is the view of myself as the imprisoning master of a being whose only desire is to run free. So the phenomenological point of view sees this relationship, it starts with this kind of experience of relationship to the world through our bodies. And it accepts, without initial questioning, the presence and consciousness of other humans and other animals. And our desire as children to reach out and to know that world takes many forms, but we really want a kind of personal contact with it, a feeling of ownership of that world, which explains the widespread desire to collect things and bring them home and treasure them, things that are, as I was saying before, are largely stigmatized in our cultural and educational institutions today. children are told not to touch. Nature is dangerous, and things will bite you, or else everything you touch you'll ruin. And some of these prohibitions might really be justified in terms of protecting rare resources, but there's an underlying message that humans are unnatural, and so we need to let nature alone. But it's just those exact things, running on the grass, climbing a cliff to pick a flower, and bringing it home and putting a grasshopper in a box. It's those things that create a real intimacy with nature that lasts a lifetime. And so it's really a problem. We can learn as children in this sort of embedded way to listen and learn from animals and plants and streams. And we can learn a kind of language where you speak with nature instead of just about nature. And without exception, every single field biologist I know started as a child who was allowed to sort of run around and do free exploration of nature. And as I said, the young children in school, they're always very interested in their relationships with bugs and other things, but that excitement is not drawn on and brought into their education. Right away, we start talking about stimuli and sensations and organ systems. So what would happen if we took a little time to think about and analyze the structure and meaning of these early encounters with the natural world? Maybe we could develop a grounding from which to think about and evaluate our scientific and technological relationship with the world. The problem with it seems to be, one, is that if this kind of free exploration of nature, there's nothing in particular that you might learn, and there's no body of facts that you can put on a test that everybody could get from that. And there is also uncertain moral ground. We may hurt or kill an organism knowingly or unknowingly. The PETA perspective tells us that we must avoid any relationship with animals lest that happen. And Dr. Gordon, cited above, tells the child that he can't have an insect collection. But notice that the killing of bugs is not usually something that's stigmatized in our culture. You can kill all the mosquitoes that you want, and you can kill all the termites in your house, and you can kill ants if they bother you. And if you cut down a tree to put up a building or even to replace it with another tree, you're killing thousands and thousands of bugs, but yet that's not a problem. So the kid who puts the grasshopper in a box and then looks at it every 5 minutes because he's sort of fascinated with it, he's the one that's rebuked because he's doing it, for no reason. So there's a funny thing happening here where from this sort of detached master of the universe point of view, we're allowed to kill all the bugs we want, but the collection of one grasshopper by a kid is suddenly a problem. So is it actually the intimacy that he's seeking that's the problem there? And so these two main contemporary narratives that we have are really two sides of the same coin. In both cases, humans are apart from nature. They're in a different realm. And because our interactions with nature are not morally clear, it seems better maybe not to do it at all. But what neither of these, the green or the DNA view of life, can explain is why I come back from a walk in the arroyo behind the college completely rejuvenated in my mind and my spirit. And they can't also explain that kind of deep intimacy that you can develop with nature. So by defining the study of biology as a scientific endeavor and severing these cords which connected us in the beginning and putting an abstract world in its place where the excitement, the things that really touch your heart and move you are sort of replaced by an abstract intellectual view where scientific discovery is the thing that is supposed to really move you, is problematic. Phenomenology reminds us that we start as members of the world and invites us to look at the quality of that membership and to see how the more impoverished and abstract perspectives of genetics or even green science grows out of it. Biology as a liberal art honors the way one experiences one's experiences with nature move our hearts and touch our spirits from an original place of communion. So now I'm going to pass the floor to Russell Winslow, Biology as Wild Ontology.
Let me first begin by making sure that you can hear me on the one hand, and on the other hand that a little bit louder, okay, and that I'm not injuring your eardrums. So I would like to begin with a blanket assertion, a blanket philosophical assertion. Namely, life did not exist until the 19th century. You may be surprised to learn this, but it's true. And we know it's true because the French philosopher Michel Foucault told us as much in his 1966 work, Le Mot de la Chose, or The Order of Things. Allow me to quote a passage to clear up any confusion you may still have. This is Foucault. Historians want to write histories of biology in the 18th century, but they do not realize that biology did not exist then, and that the pattern of knowledge that has been familiar to us for 150 years is not valid for a previous period. And if biology was unknown, there was a very simple reason for it, that life itself did not exist. All that existed were living beings, which were viewed through a grid of knowledge constituted by natural history. By this rather provocative claim, it is clear that Foucault does not mean that living beings arrived upon the Earth via asteroid in the late 18th century. But what does he mean when he says that life did not exist then? My brief presentation will offer an abbreviated reading of this claim. In considering what it means to attempt to approach biology in the manner of a liberal art, I should think that a first step would require the cultivation of a wakeful orientation to the ontological structures that subtend the biological sciences, a vision and intellectual sensitivity often missing in and or disregarded by the sciences themselves. And in my view, it is precisely such ontological foundations that Foucault's analysis of the transition from natural history to biology, from living beings to life, seeks to make visible. I will here invoke his analysis as a form of a template for thinking about a liberal arts approach to the biological sciences. A little louder, okay. Sort of closing in on the microphone. To say that the ontological foundations through which a science views its objects of investigation changes is to say that being, or modes of being, are subject to becoming. That is, being is historical. In the preface to The Order of Things, Foucault introduces one of the central concepts of his text, historical a priori. I will take the opportunity to further flesh out how Foucault uses this phrase, since it lies at the very heart of his ontological argument. Of course, as has been pointed out before, the concept explicitly invokes the work of Kant, and it is evident that Foucault has the Enlightenment thinker in mind when he first introduces the concept in the preface, while explaining that his investigation should not be confused with either that of the history of ideas on the one hand, or of science itself on the other. But rather, the work of the text will be to elucidate the conditions of possibility for the way the sciences take their objects of investigation into view. A way of asking a question with this aim might be, are there discursive conditions of possibility for the particular ways in which the sciences see the beings that they investigate? If so, how do those conditions structure our sight? Kant considered the conditions for possibility of certain kinds of cognition to be a priori, which is to say not derived from empirical experience, but rather organized by categories of the understanding in advance of empirical experience. However, Foucault, while appropriating from Kant a semblance of this notion of a priori, introduces a signal qualification, the historical. Insofar as our vision of things is shaped and determined by an historical a priori, Foucault suggests that the condition for the possibility of the perceptual grasp of an entity by the sciences requires that the scientist be always already within an historical situatedness, a discursive narrative that already fundamentally shapes what the scientist sees. Thus, Foucault desires not to investigate the particular objects of science, and not to document the history of science's progress, but rather to identify and disclose the very modes of being of a given historical period, the mode of being through which the beings of a science's investigation become seen and interpreted. For the ontological situation in which entities become visible to a science, placed within orders by it, and interrogated through its methodologies, all of these always carry with them a historicity for Foucault. This mode of being that must be interpreted in accordance with its historical situatedness is the object of Foucault's investigation in the order of things. And it is precisely this sort of investigation, not a history of biology's progress, not an investigation of the actual objects of biology, but an ontological investigation that I want to suggest might be what we talk about when we talk about biology as a liberal art. Now, Foucault argues that there was an ontological transformation between the 18th and 19th centuries, a rupture that reshapes the order of things and the very way that we see these things, as well as the sciences that perform such ordering. The focus of my presentation will be to offer a preliminary glimpse into what I want to call the lens of wild being, through which the 19th century and perhaps also the 20th and 21st centuries perceive living entities. However, I will provide some context by briefly describing the characteristics of the historical a priori of the 18th century. Foucault thinks that the mode of being of natural history becomes most visible in the image of the taxonomic table, that is to say, the mode of being of the 18th century becomes most visible in through the taxonomic table. Insofar as beings are fundamentally available to sight upon a table, there remains an implication that in the acquisition of the knowledge of the living, the very being of the organism can be removed from its variation, its complex motions, its becoming. Of the possibilities available for the sensible apprehension of the phenomenal manifold, sight holds a methodological privilege in the 18th century. Indeed, Foucault quotes Diderot's observation, quote, "The blind man in the 18th century can perfectly well be a geometrician, but he cannot be a naturalist," end quote. Moreover, what can be utilized in the discourse supported by sight must be carefully bracketed as well. For instance, Foucault argues that colors must be eliminated, for they cannot be relied upon to serve as a foundational characteristic in the composition of the parts of living organisms. We observe the commitment to the limitation of the field of vision in the following remark of Linnaeus, quote, "All obscure similitudes are introduced only to the shame of art," says Linnaeus. Thus, while natural history relies on sight, it relies on the vision of only a very few things systematically. What does the sight of natural history perceive in its black and white restriction? What do the parts of organisms look like when the area of visibility is restricted in this way? We may reduce the objects of taxonomic observation in living organisms to only 4 variables that admit of universality: the form of the elements, the quantity of those elements, the manner in which they are distributed in space in relation to one another, and the magnitude of each element. All universalizable characteristics. Thus, while sight remains the sense capacity that natural history relies upon in its effort to investigate living beings, it is a sight greatly restricted to variables that can be appropriated by discourse in a universal sense. What is given to sight can be divided into universal categories, and what remains uncertain, ambiguous, or undependable can be excised as irrelevant. Foucault suggests that this area of visibility provides natural history, and indeed the classical age, with the condition of its possibility. That is to say, the lens which excises the peripheral vision and perception of organisms, that both restricts and bestows meaning upon them, that mediates the investigator's relation to the object of inquiry, either is the very historical a priori of the classical period or cannot be separated from it. For Foucault, it is Georges Cuvier that marks the ontological transformation that makes possible the move from natural history to biology. A statement made by the late 18th century biologist Saint-Hilaire might be a heralding of the transformation that was taking place at the beginning of the 19th century. He writes, quote, "Organic structure is becoming an abstract being, capable of assuming numerous forms. In Cuvier, the living being, qua living, is no longer conceived as a puzzle of organs, is no longer understood in terms of its visible, classifiable parts. Rather, there is a priority given to function in Cuvier, and this priority should really be seen as a radical transformation of the mode of being of the living, insofar as if function represents the true mode of being of the living entity, not classifiable organs and forms, then forms can shift, and visibility becomes unreliable. The limits of the grids on the table become blurred and even perforated. The organic character of the living organism, the life of the living organism, becomes amorphous, discontinuous, non-specific qua species. In short, the kind of being that life exhibits is wild being. Thinking through the turn to life, conceived as wild ontology, requires a more sustained meditation on the relation between organs and their function. For the sake of clarity, let us consider more precisely how Cuvier disrupts the correspondence between organ and function for Foucault. Insofar as living entities were seen in classical analysis as beings present to visibility, outside of becoming, and exhaustively accountable in accordance with the grid of the table, organs and functions related to one another in a sort of one-to-one correspondence. The investigator could offer an account of the living being and its various functions, either by articulating the role its organs played in function, or by offering an exhaustive account of the morphological variables, which we saw earlier as the four universalizable categories of form, magnitude, arrangement, and number. But as Foucault suggests, to investigate the organs is not the same as to have encountered life, nor is something articulated about life in the investigation. That, thinks Foucault, requires a revolution in the perception of the mode of being of living entities. In Cuvier, we see such a revolution insofar as organs are no longer the loci of functions per se, but rather organs become taken up by functions. Functions are themselves sovereign in the new order of things, brought forward in reflection about what a being is, what a living being is. That is to say, if we wish to investigate the living being, we do not begin with what is secondary and derivative, that is, the organs, which exhibit these universal variables. Rather, we begin with the functions to which those organs actually belong. And here we start to approach the observation of Saint-Hilaire. The visible diversity of variables is no longer secured by the table, but rather from the far less visible, far more opaque, abstract background of respiration, digestion, locomotion, reproduction, etc. Moreover, and more importantly, these visible variables are not determined by their presence in this or that organ, but function is freer in its amorphous power to utilize parts that seemingly have few visible variables in common. For instance, while gills and lungs share few, if any, visible variables, they are united by the function of respiration. The function or activity rules over organs and utilizes many different forms and shapes to make itself manifest. Thus, to know a living being for Cuvier is no longer to know the organs possessed by it. Rather, to know the living being means that one has the capacity to explain the function, which may link together a variety of organs and may in fact take up virtually any visible variable indifferently. To return to the wildly different forms of gills and lungs, Foucault writes, quote, "They resemble one another because they are two varieties of that non-existent, abstract, unreal, unassignable organ, absent from all describable species, yet present in the animal kingdom in its entirety, which serves for respiration in general." Now this is striking. The organ to whose service both gills and lungs belong is not visible. It's not touchable. respiration is absent from every visible description of individual species. Yet simultaneously, it is present in each and every animal species. When form and function are separated from the mode of being that can be presented as a table of organs, function becomes unhinged from the limits of form and is released into a wild, unreal, abstract, unassignable form of being, a pulsating force that appropriates matter and arrays it into unlimited varieties and shapes, such that not a specific organ, but rather function itself may come to be in the world. Knowing function becomes central to the episteme of biology. Indeed, knowing function is a mere few steps removed from knowing life, insofar as life itself is the function for which all the other functions function. Earlier, I said that biology as a liberal art might be the analysis of the ontological structures subtending our view of living beings, the lenses through which the mode of being of living entities becomes shaped. The importance of such analysis becomes evident in the work of criticism that can be performed once these ontological structures have been delineated. And almost without comment, we can see how the being of the table impoverished our conception of living entities. But what about wild being? How might the critique of wild ontology open us to new conceptions of living entities?
Thank you. And John Cornell next with Darwin and the origins of the origin.
Am I audible? Is that an audible level? Thank you. If there is a queen of the arts and sciences today, a discipline with the authority and influence that theology and philosophy once exercised, it is biology. Specifically, it is Darwinian biology. During the last 60 years, the neo-Darwinian synthesis gathered the special sciences of genetics, cytology, field studies, and paleontology under the banner of evolution by natural selection. Today, the Darwinian worldview is widely assumed by the public and celebrated in the academy, when the other great ideologies of the last century, Freudianism and Marxism, have declined. Indeed, one might ask whether the modern university ever reached such a strong consensus about the interpretation of existence. By its own admission, Darwinism is an orthodoxy whose guardians can be counted on to bring down any critics, scientific or philosophical. I propose to show how Darwinism, though looking only like a claim to scientific truth, is also an ideology comme les autres. To be precise, it is a technico-theology, a new spin on the original modern project of the mastery of nature. To see this, one must study the background of its founding text on the origin of species and the famous argument on which contemporary Darwinian dogma is based. Here I can only sketch an outline, but perhaps enough for you to see how the metaphysics of the mastery of nature overdetermines Darwin's way of conceiving life and evolution. If we examine the implicit premises of Darwin's great book, they prove to be scientific in a narrow sense, which I label technicist. By that term, I mean a theory that presumptively exalts a human technical power into a conception of nature as a whole. The question of the ideological hegemony of Darwinism turns on the now commonplace belief that natural selection, or fitness to survive, is the key to explaining the origins of beings. This belief ultimately derives from the conviction Darwin expresses in The Origin that selection is the main means of species modification. Besides the technicist bias in his thinking, I find a metaphysical bias in this preemptive claim for selection over any deeper causes of species change. Darwin's claim depended directly on his belief in the God of science, aka the divine engineer of Isaac Newton. By examining how mechanistic theology structured his thought, we can see how biology became entangled with a system of metaphysical beliefs, as might be expected in treating the whole of creation. The same abstract system that elevated natural selection to the main principle in the account of evolution also shows us how that principle was overrated from the beginning. It is well known that for early 19th century naturalists, the providential creation of plants and animals by a creator was a given. Separate creations by God accounted at once for the proliferation of species and for their well-designed adaptations to their environments. Thus, Darwin tells us in the introduction to The Origin of Species that the theory of the continuous genetic descent of species, the very idea of evolution, could not be entertained unless the adaptation that people admire about living things was also explained. In this way, the Darwinian revolution was set up before it took place, according to the religious scientific logic of the day. That logic decreed, we must either explain the providential appearance of beings in a scientific manner, disclose by what means these phenomena originate, as Kant and Laplace did with the solar system, or persist in denying any evolution and invoke multiple miracles to account for those phenomena. In other words, establishing the fact of evolution was oddly made contingent on explaining that fact, a task one might have thought secondary and more complicated, requiring untold knowledge of organisms and their potentials. Apparently, the example of Newton's celestial mechanics held out the prospect that finding the universal law of creation could not be all that difficult. Now, Darwin tells us in his autobiography that he embraced this scientific theological system. He says that throughout the time he worked on The Origin of Species, he believed strongly in a first cause with intelligence analogous to man's. As we shall see, his metaphysical commitment had decisive influence on his theory. Darwin's ambition was to persuade people that special creation was false and the genealogical descent of species was true, but true as part of a mechanical creation issuing from laws providentially ordered for that purpose. For him, the question of the origin of species came down to discovering, in his words, God's magnificent law of adaptation inscribed in the dynamic system of the world. When eventually he had the insight that the sifting of individuals in the ongoing competition of life would in time modify a species, he understood it as the law designed for the purpose of the species adaptation. As adaptation had been linked theologically to the riddle of creation in general, he was bound to think he had now solved the essential riddle. He had found a way to turn the necessary condition of survival into an apparently sufficient cause of differential change, and so satisfy the Newtonian demand that evolution be simple and law-like. Thus, his great book simply subsumes the case for evolution under a new debate between the principle of natural selection and the old special creation. All the evidence for evolution, the genealogical kinship among species, was presented as if it followed mainly as the achievement of natural selection. Ironically, Darwin's view of natural selection was an expression of piety compared to that of his new atheist descendants. He saw it as the Creator's law for bringing about a gradual genesis, a world designed as a whole rather than species by species. Natural selection led to the benefit that Darwin called divergence of character, that is, to biodiversity. It led toward higher or more complex forms and to each being's good. The world system was well ordered. What should it matter if human beings were naturally selected into existence rather than specially created? But systems thinking had a serious blind spot. It overlooked the real question of teleology, that is, the purposive character of the organism's activity, its manifest powers of self-production, self-maintenance, and self-adjustment. Today, people assume that natural selection destroyed teleology, but the idea never entered Darwin's head. English Newtonians had long dismissed the phenomenon of purposive behavior by referring it to special laws, relegating it to scientific limbo. With no concept of the dynamism of organisms to bring to bear on their evolution, Darwin simply grafted the selection principle onto Malthus's idea of over-reproduction. If selection theory later seemed to replace organic teleology, it was because Darwin never dealt with it. Again, his aim was to find the law designed to make species, reduced to instances of adaptation. He wanted selection to be responsible not just for certain kinds of change, but for species' essential creation. That is one way that selection got sucked into the vacuum of worldview. Historically speaking, our convention of interpreting the purposive features of organisms as having such and such survival value arose not from any deep insight into organic teleology, but from a mutation in the theology of design. To produce the reverse mutation, just apply the arguments of the new intelligent design movement. They use the same mechanistic and abductive logic as Darwin. Darwin's theology made him raise selection to first principle status in yet another way. Remember, it was he who persuaded the Victorian world of the fact of evolution, as Alfred Wallace did not, because Darwin did not just extrapolate the Malthusian struggle for existence, as Wallace did, but Darwin reconceived creation, the production of novel forms, across the whole organic spectrum. He had to discover the role of human selecting in producing our domestic breeds. Previous evolutionists were not sure what factors were involved in the creation of our agricultural varieties. Given Darwin's belief that human intelligence was the mirror of God's, he thought his clarification about the power of the breeder's art justified mapping selection onto nature to solve the whole creation-evolution problem. Indeed, Darwin's belief in the analogy between human intelligence and that of the deity made the recent progress in the technological mastery of nature seem revelatory of deeper truth about the cosmos. Production of new organic varieties had accelerated with the practice of selection during the agricultural industrial revolution. On that account, Darwin thought it only natural that the true method of creation should now come to light. He scrawled in the margin of a book on cattle breeding, "As the simple principle of selection, only lately discovered, even in most reliable practice, no wonder not discovered as theory of species." Darwin's belief in the analogy between divine and human mind magnified his enthusiasm for a hidden analogy between the breeder's productions and nature's, selection being the key in both spheres. Certainly, he was right about the ripeness of the time. Natural selection, as a purported summary of evolution, could have arisen at no other moment of history than this one, poised between the old age of faith in man's godlike reason and the new age that saw this proven in man's technical progress. The 19th century's need for a simple explanation of evolution, merely to give the idea a fair hearing, allied to its technicist theology, made selection seem like the great secret of Genesis. In The Origin of Species, the theistic scaffolding, though visible, is submerged between Darwin's absolute confidence in the analogy of the art of breeding with nature. The paradigm of art appears to give the mind mastery over nature as a whole, however illusory such mastery may be. In The Origin, it works thus. First, he inquires into the causes of diversity in domesticated species, compiling the human and the non-human sources together without distinction. He finds all the natural sources of variation to be complicated and weak compared to the effect of human selection. Do the connoisseurs of pigeons and dogs not produce menageries of bizarre new types to mirror nature's manifold? The cause of dramatically divergent domestic races is therefore external to the organism. Indeed, it is artificial, though Darwin avoids the word that could challenge the analogy's application. Conversely, variability the organism's own true resource is not recognized, not accorded equal rights as a creative principle. It is reduced to serving as material, a word Darwin does use, material for the external force that presumably creates form. He does not ask if he found variation wanting because nature could not manifest under the restricted sphere of our technique all her means and impetuses as a theorist demands. He does not ask if the breeder's perspective might be too narrow, too utilitarian to encompass the proliferation of organic forms across expanses of time. The organism is a mass of statistical units that need a selector to make any shape appear. This form-matter polarity feels simple and comprehensive to the mind, which betrays its metaphysical function. It shifts our conception of nature's forming power from inside to outside the organism. The origin of species thus proceeds with its massive thought experiment, making wild organisms passive subjects in their own transformation. Darwin teaches how to imagine viable forms into being by envisioning them constantly winnowed by brutal competition. Two varieties split off only through the extermination of an intermediate type, which process, extrapolated indefinitely, is evolution. New types arise by the divergent action of distinct ecological niches that allegedly pre-exist their inhabitants. Yet it is striking how often Darwin's examples make the selecting sound superfluous. He shows plants being prodigal in variation, animals engaging in opportunistic behavior, life exploring possibilities. Abruptly, he has to remind us that such effects either precede the environment's working like a superhuman breeder or result from it. Claiming to know the main means of evolution becomes indistinguishable from performing the breeding analogy in one's head. This is why many eminent biologists reject Darwin's totalism and take up independent paths. The environment, they object, can only really test for the organism's basic viability. So long as the physiological balance sheet is favorable and an organism's features meet the conditions of its existence, it is open to it to develop by whatever internal forces are at work. We do not have to pretend to understand these forces immediately in order to recognize their significance. After all, the real evidence of the power of variation is all the extravagant phenomena of life, past and present. The panorama of nature must correct for the myopia of the breeders, whether on the farm or in the genetics laboratory. Then we see evolution as a dialectic between two great principles: the wildly diverse potentials of organic form expressed in the course of geological time, and the conditions in which any form must compete. Darwinian rationalizations have no logical precedence over the study of the beings that are. In sum, a truly naturalistic way of thinking evolution would not have adopted the creative forces, would not have placed the creative forces of change outside the organism as Darwin did when he adopted the breeder's viewpoint and, under the sway of theology, accorded it cosmic significance. In effect, he made nature mimic man. That is the essence of technicism.
Next, Llyd Wells, mechanistic telos, a little more than kin and less than kind.
Can you hear me? Let me begin by calling attention to two implications of Darwin's theory of evolution. First, living beings are related to one another and possibly stem from a single origin. Second, in part as a consequence of that relatedness, distinctions of kind, notably of species, become problematic. Indeed, in his conclusions to the origin of species, Darwin explicitly renounces the search for the essence of the term species as, quote, undiscoverable, end quote. In the context of these implications, The question that I shall address today is, what does it mean for living beings to be kin, even while they are less than kind? I shall sketch two closely related theses in answer to this question. I shall try to show that both orbit the broader problem of purpose or end, what I will call telos. Proteus. My first thesis is that evolution, as an idea as well as biological phenomenon, challenges the categories of our language and thought. It suggests that they are at best provisional. In fact, it places us in a position akin to Menelaus's when he wrestles Proteus, that minor god who, in an effort to escape Menelaus's grasp, twists and turns into every beast that crawls the earth and into water and fire as well. Yet Menelaus holds on. To what? What are we to grasp? What are we to comprehend in a protean world? After all, in contrast to Proteus's metamorphoses, it is not clear that evolution has an end. Menelaus and his men, if only they are tenacious enough, can outwait Proteus. The god, curiously, tires. He reverts to his final form, the kind that he is. But what would the final form of life be? When does evolution stop and allow life to rest in its true form? What will that end, that telos, have been, the one towards which we and it have ever been twisting and turning? What if it's not there? Can we honestly think that world? This last question is routinely answered in our modern age with little more than an expressive shrug. It's a commonplace now to abandon telos. Indeed, the teleological biologist is a heretic. But I suspect he's also extremely pious. I suspect that when modern biology sidesteps the problem of telos by invoking, for example, the language of function, eyes, we initiates say, have functions, not purposes. It has only impoverished, not abandoned, the teleological orientation that seemingly makes the world graspable. After all, it is at least partly through the extension of a mechanical metaphor that eyes are suddenly recognized as instruments with functions. The embrace of that metaphor necessarily entails an embrace of instrumentality, of understanding organs and even living beings as means. But means toward what? Have we really escaped teleological thinking if we simply don't offer an explicit answer to that question? Indeed, the question is implied in the mechanical metaphor from the very beginning. After all, would anyone say that the function of your standard machine, your iPod, your elevator, your windmill, isn't purposeful? In a protean world, a teleological biology is confronted with an irritating way that seeming ends keep turning into something else. Yet it holds on in the expectation of a final end, a true telos, a God in hand. A mechanistic biology does not avoid a similar cascade of meaning. Evolution challenges the stability of function no less than of purpose. Just as a hammer can prop up a window as well as pound a nail, so too can an esophagus develop the function of a lung. In short, both the teleological and mechanistic biologies confront a world characterized not by the absence of meaning, but by its seeming superabundance. The mechanistic response to that problem is the very gesture of measurement, the enormously powerful, metonymic reduction of the infinitely complex object to a privileged, quantifiable trait. As soon as that trait is confused for the object, as it inevitably is, the mechanistic biology has its telos. A world overrun with meaning becomes instantly graspable at the mere expense of its own impoverishment, and the wonder of sight is replaced by its shadow, the function of an eye. In this way, modern biology, in its invocation of function instead of purpose to explain evolutionary developments, has not escaped the problems or even the implicit supposition of telos, even if that telos remains undisclosed. It has avoided the word and largely by way of an unexamined rhetoric, hollowed out its possible meanings, but it has yet to begin to think a biology that does not, in an absolute sense, require a telos at all. We stand at a crossroad, either to imagine that new biology or to confront head-on why we need a telos to make sense of the living. From that crossroad, we might imagine Menelaus on a beach or perhaps in a heath. He pitches his foot against none other than Proteus and grabs on. First he grabs a bearded lion, then in quick succession a serpent, a panther, a torrent of water, a tree with soaring branches, a flame. At last, Proteus turns into a watch. Now Menelaus has him. Now Proteus is caught. All that remains is for him to tell us our future and our end. It is just possible that, however allegorical this sounds, it is the truth of the world. It is just possible that Proteus's true form is, wonder of wonders, that most philosophical of devices, a watch, what human beings use to keep track of time, if not of their boredom. But if so, forgive me, I shall pass my time, however dysfunctionally, with the more interesting metaphors and allegories of epic poetry. For 'tis the sport to have the engineer hoist with his own petard. My second thesis is that, as a result of this disruption of kinds, how we imagine those other living beings frequently and perhaps necessarily bleeds into our imagination of ourselves, however much our claims might seem insulated or restricted. This indeed might be the foreseeable consequence of kinship, of that biological blur in which kinds can be declared more easily than found. In lieu of a demonstration, let me give two examples of what I mean. My first will be taken from Maimonides' The Guide of the Perplexed, a text I choose for the sake of convenience. Similar arguments could be made about many other texts in the Western tradition, notably those of Descartes, but also, if in different ways, even of Aristotle and Plato. In the guide, Maimonides argues that providence is consequent upon the overflow of the divine intellect into its human counterpart. It has, quote, singled out the human species alone among all the species of animals, end quote, because, according to Maimonides, humans alone have intellect. He uses this conclusion to justify our treatment of animals, our use of them for labor and for food. It's true that he acknowledges that, quote, to avoid causing suffering to animals is an injunction to be found in the Torah, end quote. But even this injunction is for our sake, not for the animals. It is to protect us from acquiring moral habits of cruelty where no utility is served. Animals are a means for Maimonides. They are tools, food, objects against which to develop moral habits rather than subjects with whom to enter into ethical relationships. For Maimonides, the telos of all other living beings is the telos humans make of them. This is perhaps not so different from understanding them as watches. But where does this human distinctness from animals lead? The answer may be surprising. It leads to the retreat of the distinction. Quote, as for the ignorant and disobedient human beings, Maimonides writes, their state is despicable proportionally to their lack of this overflow of divine intellect, and they have been relegated to the rank of the individuals of all the other species of animals. He is like the beasts that speak not. For this reason, it is a light thing to kill them, and has been even enjoined because of its utility. This matter is one of the fundamental principles of the law, end quote. We should wonder what is fundamental about this principle. We should no less wonder what the utility is in service of. Is killing ever so light a thing that we shouldn't know its end, its telos? But is it clear that we can know the end of death? I also hardly need to point out the political ramifications and appalling history of the thinking that, through recourse to utility, reduces human beings to mere means, indeed to mere animals, as prelude to justifying acts against them that are often, with painful rigor, described as brutal and bestial. Which are the beasts and which the human beings? The perpetrators or the victims? Who's who? Let me add that the tragic 20th century history to which I am in part alluding was often explicitly justified by recourse to Darwinian doctrine. It should confront us with a question of immense and disturbing scope. If we are all somewhat more than kin and less than kind, can we truly think of other living beings as means while preserving for ourselves the category of ends? This question should also be alive in the perhaps surprising arena of modern education. This is my second example. I'm not the first to suggest that a great deal of modern education looks like animal training. Everett Dean Martin says so in his 1926 book, The Meaning of a Liberal Education. There he calls attention to two criteria that distinguish animal training from a liberal education. First, the liberally educated think of education and of themselves as ends, not as means. Second, they don't simply try to solve an immediate problem, but they seek insight into the situation as a whole. The liberally educated seek ends and wholes. Animal training, in contrast, discourages both modes of thinking, both modes of self-consideration. It is limited to questions like, how do I use this to get that? To learning by conditioning rather than by developing insight into a situation, and to following instructions and doing as you're told. According to such a description, I suspect we would have a hard time distinguishing the vast majority of modern educational projects from animal training. But why do we associate this training with animals? Is it because animals are limited to this type of education? Or is it rather that this type of education is what we enforce upon them, a telos that we declare for them? Put some apes in a cage. Deny them food, but place bananas just out of reach. Eventually give them a stick. What questions occur to the apes? The apes who dwell on speculative questions, questions about the justice of the universe, or about the darkness of the human soul, or about their own proper self-conception, starve. The more intelligent apes, however, are driven to instrumental reason. They are the ones who ask, how do I use the stick to get the bananas? In this pedagogical program, the ones who strive to think of at least a potential world of ends, including of themselves as ends, fail, confirming our low opinion of them. Those who think of a world of means, who allow themselves to be reduced to mere appetites in need of satisfaction, get bananas and our praise. I want to emphasize that I have no idea what an ape thinks about in a cage. I wonder about it, and I think it's important to wonder about. That some can be coerced into a demonstration of instrumental reason teaches me little about them and more about us. It leads me to worry about what we are doing to ourselves when we reduce education to the approved of use of instruments that we make little attempt to understand, and to the pursuit of jobs whose value is measured in dollars rather than bananas. To my eye, it looks like the distinction in kind that we postulated between ourselves and other living beings has eroded away. A secret kinship in which neither party is well served has instead betrayed the singularity of kinds. Would we believe that this is a world without telos? That a world without telos is a world only of means? Or is this instead a world of impoverished telos? A world of telos violently imposed? A teleological world with an end that no one should strive for? Why then are we striving for it? Does being more than kin and less than kind have to lead here? Sometimes the best response, wakened by lips that perish, is to call out, to protest, to scream, to choose rather than to argue. We can go another way, travel a different path, with that kinship that erodes our kinds. We may have to. If we would think ourselves as ends, that thought cannot be limited to ourselves. If we would distinguish means from ends, it will not be a distinction of kind. Rather, it will be a performative distinction that possibly with an inhuman vigilance, we must tirelessly choose and can live only and ever precariously.
And last, Greg Schneider with the fabulous title, The Human Microbiome Project, Me and 100 Trillion of My Closest Friends.
Okay, hang in there. We're going to get there. So thank you for your patience here. In these few minutes allocated to me, I will take a look at the. I swear I'll go fast. At the earliest startling results released just in 2012 of a massive international collaborative scientific project known as the Human Microbiome Project. The project, which is attempting to categorize the vast number of microbiological species and organisms that live in and on the healthy human body, raises important questions about what it means to be an individual human being, especially if that individual involves a community hosting some hundreds of trillions of its closest friends. So, if you permit me, I will attempt what might be called a liberal arts reading of these initial results. Specifically, I will ask two questions. One, what does it mean to be an individual human being, given these results? And two, what ethical obligations, if any, should those individuals consider in regard to their microbiological fellow passengers? As a point of departure, I will look at the language employed to describe these initial results, hoping to find clues in that language for guidance as to how to consider the implications of this latest adventure in the biological sciences. The overall project, coordinated by the U.S. National Institutes of Health, involves roughly 200 scientists at 80 institutions around the world who aim to sequence, categorize, and catalog the genetic material of the microbiological organisms, largely bacteria, that live in, on, and alongside their human hosts. The initial results, which were released just last June in the journal Nature, rely upon specimens gathered from 242 adults, 129 men and 113 women. From the initial 600 volunteers, the researchers selected those who met rigorous exclusion criteria that allowed the subjects to be deemed, quote, healthy for the purposes of the study. Anyway, a lot of people were sent back for dental work, by the way. The investigators collected stool and saliva samples. They took other samples from the front of the elbow and the folds of the ear. They scraped the subjects' palates, tonsils, and throats, swabbed their gums, teeth, and nostrils. In total, women were sampled in 18 places, including 3 sites in the vagina, and men in 15. In order to assess for stability, the researchers resampled subjects 3 times during the course of the study, taking the initial 4,788 specimens up to a total of 11,174 samples. Wouldn't you have liked to have been a participant? Yes. Yes. All of this sampling revealed a number of startling results. The, quote, healthy human adult houses hundreds of trillions of bacteria, 100 trillion in the digestive tract alone. In fact, the average adult in the study had 10 times as many microbial cells as cells descended from the germ cells of his parents. In addition, these microbial cells are markedly more diverse in genetic terms than their human cell counterparts. The Human Genome Project demonstrated that there are approximately 23,000 different genes on average in an individual human. The Human Microbiome Project now estimates that the commensal bacteria that reside on and in that individual's body incorporate a total of some 3 million different genes. These parallel genomes represent an intriguing partnership. In exchange for shelter and raw materials, the members of the microbiome help feed and protect their hosts. These bacteria are actually essential for survival and are integral to the host's well-being. Yet the parallel relationship can go awry, affecting the health of both the bacteria involved and the host. In fact, according to a 2012 Economist article summarizing these results, the long-term goals of the entire microbiome project involve assessments of human health and disease in relation to the microbiome, with the hope that we might discover tools for diagnosis and treatment of disease by looking at the bacterial growth patterns involved. The results of this initial study strain the use of language. Gina Collada, in her New York Times piece on the study, tended to focus on the sheer numbers involved and the librarian-like cataloging and computing power needed to even look at our fellow travelers. In the midst of her language, the human sounds more like a library, always threatened with ill health should any of the books in the collection be improperly arranged or checked out. The writers in The Economist stressed the idea of systems, organ systems, ecosystems, trying to find a place for the microbiome within the system that is the human being. Specifically, the authors spotlight the idea of an organ, with the microbiome playing a role analogous to the liver or a kidney, or more aptly to the immune system. In other words, quote, the immune system, for example, consists of cells scattered all around the body, but it has the salient feature of an organ, namely that it is an organized system of cells, unquote. The microbiome is similar, weighing, just like many organs, about 1 kilogram or 2.2 pounds. Think about it and your own weight. It is organized and consists largely of bacteria from 4 different groups called phyla that perform specific biochemical functions. If the balance of these functions in any body area is disrupted, the human host becomes susceptible to disease, similar to the way in which illness emerges if a function of some particular organ goes askew. As an aside, one particular culprit in sending the microbiome askew lies in excessive killing of needed bacteria, either with antibiotics or cleanliness overdone. Perhaps this latter fact might be of interest to that cadre of Johnnies who resist showers or cleaning their room. You could claim you're doing it for your microbiome. So it's very good. Organ stems from the late Latin organum, church organ, which is in turn derived from the earlier Latin meaning implement or instrument, and the Greek organon, literally that with which one works. The word bears certain assumptions, though, if used in this context. Are the microbes that inhabit the human body part of that body in the way that the kidneys and the lungs or even the cells of the immune system are? In addition, are these organisms merely tools or instruments, musical or otherwise, for our use? The scientists who authored the Nature article gravitate toward the language of ecology and epidemiology, emphasizing words and phrases like human-associated microbial communities, ecology and populations, diversity and abundance, mutualism and competition, habitats and microhabitats. In the midst of such language, the human being sounds more like a habitat or nature preserve than an individual who thinks, feels, and dreams. The scientists use the word community in a way that has been used by ecologists for decades, a way that incorporates the tendency of modern science to delineate parts while putting aside the whole to examine. This language attempts to carve out a part in space in which certain smaller living parts live and operate. Specifically, in ecology, community refers to a group of plants or animals living in a specific region under relatively similar conditions, or just the region in which the organisms live. Even with its limited use in the scientific literature, I would like to suggest that the word community offers richer possibilities than the more pedestrian catalog and the more utilitarian organ for thinking through some of the implications of the Microbiome project. Beyond its ecological usage, the word has deeper roots built upon the Latin communis, or common, that hint at varieties of commonalities beyond place and condition. The word carries with it an acknowledgement of the tension between the individual and the collective, suggesting that the constituents of a community share some things in common that must be recognized. It will be my contention that the Human Microbiome Project forces us to think of ourselves as members of and hosts to incredibly diverse multi-species communities, and that as such, philosophic and political claims that we are atomistic and autonomous discrete individuals are not tenable. If you will permit me a little leeway, these questions regarding how exactly an individual is embedded in a collective remind me of a long-standing debate in ethical and political philosophy between those like Aristotle, who claim that social life is fundamentally communal, and those like Hobbes, who claim that social life is the product of an association to maintain order via enforceable rules. In a more contemporary form of that debate, a school of thought that came to be known as communitarian has arisen, which includes a diverse variety of thinkers who consider Aristotle their intellectual forebearer. I recognize that the word communitarianism has now become kind of a polarizing political term. By the way, George W. Bush and Barack Obama both claim to be communitarian, so that's interesting. So, and it's a term that it's both celebrated or vilified on both the right and left, but it is a philosophical movement that I once studied in graduate school, largely in association with studying ethics. I hope that you will permit me the association between the words community and communitarian and allow me to reflect upon certain aspects of the philosophical movement that might be relevant. One organizing communitarian thesis is that the community, rather than the individual, the state, or the nation, is and should be at the center of our system of values and our examination of the human condition. This claim harkens back to Aristotle's Politics and the characterization of man as a political animal. Within this philosophic framework, community can be understood as a group of people living a common life through reciprocal relationships. The philosophers Alistair MacIntyre and Michael Walzer, with whom I am most familiar, often earn the name communitarian, though they themselves shy away from the term. Though their formulations are significantly different, their philosophies emphasize collective values like reciprocity, trust, and solidarity. By their very nature, these values cannot be enjoyed by individuals as such and require a threshold recognition of intersubjectivity. In brief, each person's enjoyment depends on others' enjoyment. They also argue that the commitment to public goods, to facilities and practices designed to help members of a community, serves both the common and personal lives of all members of that community. Let us now return to the two questions that I raised at the beginning, keeping in mind this admittedly brief sketch of the obligations and promises of community and communitarian thinking. These two questions, somewhat expanded, are one, what does it mean to be me when my very continuance and sustenance relies on a community of multi-species others? And two, what, if any, ethical obligations should I consider toward those living non-human parts that constitute that me? Do I have responsibilities that I should consider in relation to these living non-human parts that make me up? By way of an attempt to outline an answer to these questions, I will make just some brief remarks. Underlying these remarks is a paradoxical contention that an individual human both is a community and a member of one. First, let us begin with the hypothesis that the communitarian contention that humans are always embedded and embodied in community bears some truth in it. But let us add the perhaps more radical proposal that the community involves non-human as well as human members. If this hypothesis is correct, then who I am as an individual depends very much on the bacteria residing on my skin and in my mouth and in my gut, just as it depends on the human community in which I was raised and those communities where I now live and work. In a very real way, I am a community. The cells derived from my human parents help make up one and arguably the most important member of that community, but the bacterial members deserve recognition as well. Second, let us take up the challenge of some communitarians to embrace collective values like trust, reciprocity, and solidarity, and some notion of intersubjectivity. What might these values look like when speaking of the non-human constituents of our bodies? Let us take a medical example. The case of the gut bacterium known as Helicobacter pylori. This opportunistic and tough little corkscrew of a bacterium, it's cool looking, you should see it. Was discovered in 1982 to live in the human stomach and to be associated with gastritis and peptic ulcers. Soon, a worldwide war on the microbe ensued, and its presence within the human microbiome occupying the stomach has plummeted. Alongside that decrease, there have been parallel increases in the rates of asthma, obesity, and cancer that have strong connections with the absence of this lowly member of the stomach habitat. Now we are in a state where we are thinking of introducing H. pylori to some patients and being very careful in eliminating it in others. I might suggest that thinking of bacteria always as enemies to be cataloged or as invaders in the organs or tools that make up the human body leads to this current medical problem. Perhaps we should always consider microbes as members of a more or less well-functioning community. In this way, we might be a little more hesitant to declare war on a member of that community. As an individual with bacterial pneumonia, the proper response might be to eradicate the unhealthy visitors. But we still might not want to take that eradication lightly. Eliminating those bacteria necessarily disrupts an entire community of interconnected organisms. Like it or not, we are in solidarity with a whole spectrum of fellow travelers that we cannot even see. The process of modern science yields incredible amounts of information about the living and non-living world around us. This information has provided us with comforts and cures beyond anything its earliest progenitors could have imagined. Yet science struggles to come to terms with its own results. It strains and reinvents language, resting on assumptions that go unexamined for decades, for centuries. I have been arguing that we must go beyond the scientific, even if we borrow some of its own language, in order to rethink how we handle the information that science engenders. The question of to whom and to what we turn for guidance remains.